Hi, this video should walk through two different models and one simulation that you can use in order to look at common problems in different ways and to find root causes and resolve them once and for all, instead of trying to fix symptoms and keep on experiencing the same problem. And we are going to use here a pretty common problem that we all, I think, familiar with, which are purchasing and contracts. So purchasing has tons of contracts that they are being requested to process, mainly from IT and marketing, and they are failing for certain reason that we see later to provide signed contract back to those departments within the SLA, which actually have a negative impact on IT and marketing. And what this diagram is doing is, it's called a causal diagram. And what you can see here are the main element in the system, how they are impacting one each other, whether it's positive or negative. And you can see that the relationship here are non-linear intentionally. And you can see that there are loops here that might be negative, positive, or sometimes they can be balanced. And the way that it works is pretty simple. So vendors has a positive impact on IT. They are adding resources IT needs in order to move forward. IT obviously have a positive impact on vendor. They are adding the money, and same goes to marketing. On the other hand, marketing has a negative impact on purchasing. They're adding them work that they are struggle to do, and the same IT. And purchasing actually needs, due to the policy of risk averse, to send every contract that has people on site to review by HR, and every contract to review by legal. Legal and HR has different work to do, so they develop a queue and they develop a delay when it takes a lot of time for all the contract to come back to purchasing, to be finally processed and sent to marketing and IT. So due to this activity, actually, there's a negative impact on IT and there's a negative impact on marketing. And what we see here is like pretty negative process that actually also impact the NPS of SSMP and create another flow of negative influence on purchasing. Pretty bad situation. Now, it's important in this diagram to understand whether there are positive or negative influence, because this diagram can leverage archetypes that define if a given type of loops, whether they are positive, negative, or balance, exist between different elements, that an archetype that define a known issue in the system and known solution in the system. For example, there is one here that called the common of the strategy. I forgot. The tragedy of the common. Sorry, I have to look. I forgot about it. So the tragedy of the common is a known one. What happened is that purchasing is actually a shared resource that consumed by those two, and none of them is paying attention to purchasing need. They all assume it's part of them and they can bombard it with work. And in reality, what happened that it's a tragedy because they are suffering and everyone suffers, and this is a known problem with a known solution. Over time, you start to have your own type of archetypes. For example, we call this flower of four negative starvation, and it's a common one that we see as a result of different policies that put in place that actually suck everything from here and has a negative impact on those two. The upper one, usually the negative impact will be limitation, and it has negative impact on the lower one, which is usually more work that they can process. And this is causal diagram, pretty straightforward, but very abstract, helps you to understand the problem high level. And they are helpful in order to find archetype, and they are helpful in order to create the other diagram, which is a flow and stock diagram. And flow stock diagram actually based on causal diagram. So every element in the causal diagram is translated here into a variable which holds a constant or a calculation, a stock which is kind of a sink that has different level. For example, we have here 10 contracts into pipes that move data, or in this scenario contracts, from one sink to another. So obviously whatever goes out from here comes to here, and a variable that can has constant, for example, the number of contract that every vendor is going to generate is between random number between 1 to 10 to depict reality. Flows has logic, so you can create here any logic that you want. For example, here we are multiply them to define the number of contacts that are coming in, or you can use more advanced logic in order to define that if there are more than 50 requests for contract to be processed by HR is going actually to halt down and just provide the 50, all the rest are going to be kept inside and queued inside HR, which actually caused the delay that we saw here. So we are depicting the delay here in the logic. Loops are also here, whatever they are defined by flows or by links. You can see that there are, here it is, you can see that there are loops within loops, and there are actually several loops that create non-linear relationship between all of those elements, although at high level it looks linear and more familiar. And the idea of those models that once you define this logic, you can run it as a simulation. And what simulation will do, you will define how many times you want to run it, and it will run it as many times as you defined, and it will follow all the logic that exists here. So the contract will flow. Here we are going to capture the number of contacts that were requested by purchasing. Here we are going to measure the number of contacts that are ready to be processed, which means they approve it, they approve it, and they approve it. And we are going to divide the available by the requested, and we're going to have the SSMP efficiency, and then we're going to do a little bit of average. We are going to run it, I think, for 200 times, and we are going to see how it looks like. So we need to start with, okay, we are good, so no solution in place right now, just the problem as we saw it. The efficiency should go down to around 20. That's the common one that we usually see. You see it's starting to go the direction. Oops, it reached the 20. Okay, so this is more or less depicting the reality that we saw when we started. And now we can discuss the solution. So the solution wasn't to replace the head of purchasing or people in purchasing or redesign the purchasing process, which all of those has been done several times without any success. The solution is slightly different, and it was helpful to see it here. And this is actually a policy. So in order to resolve the problem, we need to reduce the risk averse of the company and enable element that dealing with purchasing in IT to actually process contract and prevent all the contracts from going through HR and legal. And the way that we did it is by defining training materials that define to IT what is the minimum and maximum that they can receive or accept in contracts. So IT can review all the contracts, and if the contracts are within a minimum and maximum that were defined, they need to let purchasing know, and purchasing doesn't need to involve HR and legal. They review it as well, and if everything is okay, another balance, they simply sign the contract, process them, and now you start to kind of bypass those two queues. And the way that the model is doing it is by defining here a factor, which is how many which is what is the percentage of contract that we want to bypass, HR and legal. And we are going to use it in order to run certain scenario to find out what is the percentage that we feel comfortable with risk-wise that will give us enough improvement in performance comparing to what we have now. So this is what we have now. We are going to run it now with 10%. I'm going to change the speed to be full speed to save time. So what, let me increase it a little bit. You see here a change. It will start to be more plateau than this one. Percentages are much better. We can try to move it to 20% and run a simulation. It will be better than the previous one. So this was around 50. This is around 70. Still plateau, but better results. And we can run it again based on 0.3. And this is going to be much better performance. And now you can start to do analysis and say, okay, based on those three scenarios, what is the risk that I'm willing to take comparing to the advantage that I see between what we started and the different scenario that we have. In this particular situation, they choose the 20%, so they were willing to take 20% risk in order to gain significant improvement in the processing of contract and actually enable IT and also marketing to get better performance and to prevent purchasing without even purchasing wants to, but that was the reality, to slow them down. So that's a simple example. I hope it will helpful for you. You can follow the same logic trying to resolve your own problem. Always remember that whatever is obvious is usually not the solution in complex situation. It's the non-obvious that is the solution for your problem. Thanks for your time and bye.